Okay. So students, this is Cambridge IGCSE ATP Physics, Paper 6, Alternative to Practical, October, November 2020. And let's start with the question number 1. The question 1 says a student determines the density of the modeling clay by 2 methods. So there is a first method in which figure 1.1 shows one face of the piece of the modeling clay that the student uses. This is sample A. The student measures the depth of the sample A as 3.2. It's already given. So we have to measure and record the length and the width of the sample A of the modeling clay. So basically, since I'm taking the values, because it's already drawn to the actual size, so you need to take your ruler and scale, and with the help of that, you have to measure the actual value. But since I'm using the soft copy, so might be there a slight difference in my value. So take the proper value. The length is 3.1 centimeter and the width I've taken is 2.7 centimeter. But I would recommend you to take it properly and find out the exact value, right? Now, what we have to do next, we have to find out the volume by using the same dimensions 3.1, 2.7, and the depth, which is already taken by the student, that is 3. So let me multiply both of them. This 3.1 multiplied by 2.7 multiplied by 3.2. So I get 26.784. So I am going to multiply the three values here. VA as 2.26.784. Basically, it's 784, but I'm going to take the value only till three significant figures. So this is the volume that I've taken it from the dimensions that is given as length, width, and depth. Now, in the next part of this question, they're asking us to calculate, record the mass of the sample A to the nearest grams. If you see the balance, it's written 50.78 and it's written gram. It means 50.78 grams, but we have to find out to the nearest gram means we have to take it, we have to round it to the nearest whole number. Nearest whole number means just before the decimal, we have to underline it. We have to see that what is after this. After this is a number which is from 5 to 9 category. So we are going to take the value. We are going to add 1 to this number, which will make it 51 grams. So after taking the mass to the nearest grams, it's 51 gram. Now, in the next part, they're asking us to find out the density by taking the mass and the volume, which we have found in the previous part. So I'm taking the mass as 51, the volume as 26.7, and now I'm going to find out the value by dividing both of them. So let me divide that 51 divided by 26.7, and my answer is, as 51 divided by 26.8. I rounded it to this basically because it was 26.78. So I rounded it to 26.8 in the previous part. So I'm taking 26.8 here. So now I'm dividing it 51 divided by 26.8 and it's 1.90. So my value of density here is 1.90 gram per centimeter cube. So because the volume is in centimeter and the mass is in grams, so the density would be this one. In the next part, they say that the student record the volume of the cylinder. Again, there is another volume, but this time there is a volume of the measuring cylinder. It's a type of a cylinder. You may say that this would be a type of cylinder. And in that cylinder, there is some kind of water level is there already. He records the new reading of the water level in the measuring cylinder. So maybe there is a water level, like we can say that the water is still like this is the water level. So you can say this is the water in this measuring cylinder. But now we have to calculate because this is the measuring cylinder. This is the volume of the water level in the measuring cylinder. So now what we have to do, we have to calculate the volume B of the sample B using this equation. VB is equals to V2 minus V1. So now we have to find out the value by subtracting 180. Now let me take it here. VB as V2 minus V1. So it's 182 minus 150. which is 182 minus 150, and I got 32 centimeter cube. This is 32 centimeter cube. Now the mass is already given. We will be taking this mass and this volume. The volume is 32, the mass is 60, and now we have to find out the density once again. So let me take the value. This would be like, just a minute. Okay, so now I'm going to take it, the density as the mass is 60 divided by this as 32. So let me divide 60 divided by 32. So I get 1.875. Nearly, it's like 1.875 means it's almost 1.8, 1.9 basically, because when we say that 1.875 and I round it, it's already 1.9. Maybe I can say it's 1.87. It's also or 1.88. So nearly equal to the previous value. Now, the students suggest that the density of the modeling clay does not affect by the mass or the volume of the sample used. State whether your results agree with the suggestion. Yes. We would also say, because there is no effect. Yes, the answer is correct. Yes, there is no effect, because if we see the values in both of the questions, method 1 and method 2, we almost found the same value, like 1.9 gram per centimeter cube in that and 1.9 gram per centimeter cube over here as well.